Production of Real Ag is made possible in part by an underwriting grant from Kansas Soybean Commission. The soybean checkoff. It works for everyone.
I keep reading about engineered corn, but I don't know what that means.
Spring water, purified water, what's the difference?
Is imported beef safe for my family?
Consumers want to know the facts about the products they buy. That's where Real Ag comes in. From plant to plant and from pasture to plate, Kyle Bauer and the Real Ag crew find the facts to help you sort the truth and help you understand Real Ag. Now here's your host, Kyle Bauer.
If you've ever owned an animal, you know they produce waste. In agricultural operations, these waste products need to be dealt with. Manure is our topic today on Real Ag. Entities that deal with manure regularly refer to the process as animal waste management, and it's much more complex than you might think.
Livestock waste management would basically center around how the waste is produced, how it's collected, transported, stored, and ultimately used. And within Kansas, the vast majority of the uses are as fertilizer on agricultural land. A confined animal feeding operation, from a practical standpoint, is basically a facility where livestock are confined either in buildings or with pen fences for the purpose of livestock production. All their needs are met within that facility, providing feed, water, medical care, all those sorts of things. Because of the confinement aspect of it, that's where the regulatory authorities get involved. It's mainly focused on the waste production and how that waste is managed. If a facility does not manage its waste properly and is not currently permitted, they will come under the authority of the state agency and have to make the necessary improvements to achieve proper waste management. The second factor is, in order to have a productive facility where animal health is at the level that it needs to be, you have to have good waste management. You can't separate that. And the third point is, if you have to manage waste, you need to make the best out of it. And in Kansas, most of the time, it's a very useful and productive fertilizer for crop production. Well, the storage facilities for animal waste really vary with the type of livestock and the type of operation. We deal primarily with beef cattle production, and in that sort of a system, the waste is initially, the solid waste is initially stored within the pens. The pens are cleaned on a frequent basis, and that waste is generally stockpiled and ultimately taken to agricultural land, to cropland fields, and spread as a fertilizer. The other waste that we deal with is runoff. When you get an intense rainfall over an open pen type system, runoff is produced. For the EPA or federal sized facilities, it's a requirement that all the runoff that comes off the pens and related facilities has to be contained. Typically, we store that in an earth waste storage pond or lagoon. That's sized to contain up to a 25-year rainfall, which is a pretty substantial rainfall. And after that is caught and stored, it is generally ultimately pumped again and used as a source of irrigation and fertilizer for crop production.
Most people tend to focus on storing the waste, and the agronomist takes the next step and focuses on what do you do with that manure after it's been stored. And they focus on balancing the value of that manure, the nutrients in that manure, with the crops that manure is applied to. And that manure makes a great fertilizer. Manure has been used since biblical times for fertilizing cropland. And so the agronomist tries to look at the nutrient content of that manure and prescribe a rate for this particular field or that particular field based on those field conditions and the crop being grown.
For swine production, probably the most prevalent type of system is an enclosed building. Probably the most common method of waste collection and storage is a pit underneath the building. In some facilities, the waste accumulates in the pit and it is then flushed into a waste storage pond or lagoon, where again it's contained and ultimately pumped with an irrigation system or a similar system to use as a crop fertilizer. There are also systems now where they just, the waste is removed directly from the pit and taken directly to the field. There is no lagoon in the system, and we're seeing that as being more prevalent.
It's really important when working with manure to have good data to work with. And one of the things you'll see if you work with manure from several different operations, even if they're similar types of operations, the manure can vary significantly. And even at one particular operation, it can vary throughout the year as seasons change or rations change. So it's really important for facilities to sample that manure and send it to a laboratory to have an analysis done. And it's a very precise analysis, similar to if you were testing your water, if your city is testing their water and they're going to submit that, they have regulations that require them to submit that. And regulations, depending on the size of the operation, will require a certain level of testing. And so they submit that, and that report then will give them how much nitrogen's in that manure, how much phosphorus is in the manure, how much potassium, other micronutrients like sulfur, zinc, iron, any of those things that can provide value to that crop. Both farming systems and livestock production systems have advanced. The level of planning and effort that goes into manure management and specifically nutrient management has also advanced. As double cropping systems, more intensive cropping systems have become more common, oftentimes your window of opportunity to apply that manure has narrowed and gotten smaller. So it's very important for producers to look a year out, maybe more than that, when planning crop rotations, when looking at their waste production, to determine, okay, when am I going to take advantage of open periods on that field to apply this waste. You look at the manure sample that you have, and that tells you how many nutrients are in that particular volume of manure. You know what's in your field, and then you can say, okay, I'm going to grow corn on this ground this year, or I'm going to grow alfalfa. And there's a lot of published data out there on how many nutrients that crop is going to remove, or what's the ideal fertilizer rate for this particular crop in these conditions. And so with that data in hand, you can determine, what am I deficient on? Do I need more nitrogen? Do I need more phosphorus? And try and balance your fertilizer rate as well as your manure application rate, because oftentimes you're mixing and matching to get the ideal scenario to maximize crop growth, at the same time minimizing any nutrient loss from that field. And so with all that data in mind, you try and reach a equilibrium, so to speak, with all your different factors to get the best possible scenario.
Manure needs to be collected, stored, and transported, and every step of the way is very tightly regulated.
Livestock production in Kansas is really big business, and it's been an industry that has really grown and developed relatively quickly over the last 40 or 50 years. And so as it's grown and as it's developed, so has its responsibility to protect the environment. And I think that we can be proud of the job that livestock producers in Kansas have done in taking that responsibility seriously. We know what the rules are, and we know how to comply with them. And so not only do we protect the public health and the environment, but we allow the industry to grow and prosper, knowing what those rules are.
There are basically two sets of regulations that we work with. There's a state of Kansas set of regulations that have a definition of what a confined animal feeding operation is, and there's also federal regulations that are provided by Environmental Protection Agency.
A state certification is a document issued by the Secretary of the Kansas Department of Health and Environment that shows that that facility is operating in a manner not to create a significant pollution potential.
You know, one of the things that makes Kansas attractive to the state's livestock industry is the fact that we have a lot of open space. And when you get right down to it, the further that you can keep livestock from today's population, the happier everyone is. And a facility today that's over 1,000 head is required to be at least 4,000 feet from the nearest habitable structure.
Those regulations vary across the state depending on the groundwater resource that's trying to be protected and the sensitivity of it.
The Kansas Department of Health and Environment has 3 different risk categories set up for the protection of groundwater. The most restrictive being facilities that are located in the aquifers, and then we have facilities that are located in sensitive groundwater areas, and then the third category is for facilities that are located in other places other than the aquifers or sensitive groundwater areas. So there is a risk-based system for the protection of groundwater. For the protection of surface water, the regulations are pretty much the same across the state. However, we can evaluate on site-specific facilities, and the facility can request a variance to certain requirements as long as the intent of the requirement is met.
The regulatory agencies overseeing the industry are very diligent and very thorough, and while that can be a frustration for those of us in the regulated community, it's important to the long-term ability of the industry to continue to be successful in the state. So, you know, it's not uncommon to see a facility out of compliance. The important thing then is that operation, and it shouldn't be alarming. The important thing is that the KDHE and that producer then work to address those concerns in a way that continues to protect the environment and allows that producer to continue to operate and continue to be in business.
KDHE regulates all species of large animals. This includes beef, swine, horses, goats, poultry, sheep. In addition to the species, KDHE also regulates livestock truck washes and livestock markets. A facility that has 300 animal units or more must register with the Kansas Department of Health and Environment. We also require any facility that poses a significant pollution potential, no matter what size, to register with the department.
One of the important things to recognize that is the fact that livestock production and how we handle our waste is a heavily regulated part of our business, and it's a very important part of our business that livestock producers take seriously.
Once a facility receives a permit, KDHE will conduct routine compliance inspections of the facility and/or complaint investigations if KDHE receives a complaint from the public. In addition to these inspections and investigations, every 5 years the permit must be renewed for the facility, and we will do renewal inspections at that point as well.
You know, anytime you look at food safety and oftentimes the question of E. coli and microbial organisms present in that food will come up. And there's a lot of regulations out there right now that seek to address that. You know, manure has been used since biblical times for fertilizer, so it's not a new method, but it's important, and that's why there's regulations that address it, that manure is used with the crop being grown in mind, so that if you're producing something like wheat, for example, that's grown above ground, the producer is going to apply that manure, then grow the wheat, and that manure is going to stay in the ground and provide valuable nutrients for that plant to grow in a very natural sort of way. And whereas if you had something like potatoes that you're growing in the ground, you know, there are setbacks in terms of time and when that manure can be applied, and how long you have to wait before that crop can be grown, to make sure that you consider any food safety implications that go along with using something like manure and concerns about E. coli or something of that nature. So it's regulated to try and prevent that, and that's a good thing.
Animal waste is primarily used as fertilizer, and despite new chemical-based fertilizers, it's still widely used.
One of the key reasons that manure is more valuable as fertilizer today is simply the cost of purchasing commercial fertilizer. As the cost of commercial fertilizer is driven up, alternatives are looked at, and manure is a very valuable from a nutrient standpoint, but also an economic standpoint when we look at it in comparison to commercial fertilizers. Manure contains a broader spectrum of micronutrients, organic matter, and brings other things to the equation that we don't get when we just go purchase conventional fertilizer.
Another point to consider is with the rising price of commercial or synthetic fertilizer, livestock waste-based fertilizer is a lot more competitive and, as we mentioned, has the added advantage of some additional nutrients.
As crop genetics have allowed us to produce or have the ability to produce more per acre, in order to do that, we have to provide everything that plant needs from a nutrient standpoint and able to achieve what it genetically can. And so, not just the big three nutrients are important anymore, but making sure that the entire soil health allows that plant to achieve its maximum potential. Another key thing to keep in mind is that from the standpoint of the crop being produced, it doesn't matter if it's manure or compost or commercially purchased fertilizer. The end crop is the same and it's equally as safe. So it's a matter of economics on the industry side of the equation. How can we produce that product at the lowest cost and with the best combination of our resources? So at the end of the day, the product provided to the consumer is going to be the same.
The disadvantages of using animal waste-based fertilizer is generally you have to apply a lot greater volume to get equivalent amounts of nutrients, and that translates to basically application costs. In the case of solid manure, you have to basically transport and apply a lot of tons in order to get the full value of it. In the case of liquid manure, you're not only applying the nutrients, but quite a bit of water as well, and it costs money to pump water.
There's been stories, and oftentimes you'll hear stories about manure application in a negative light, and that usually comes from an over-application of manure or an application in a less than ideal way. Manure contains very valuable nutrients, and those nutrients, if used correctly, provide the basis for a great crop. But just like commercial fertilizer, if you put too much on, if you put on too much nitrogen or too much phosphorus, there's a risk of that leaving the field, being washed off during rain or leaching down through the soil into the groundwater. And that can cause a problem with water quality, whether it be groundwater quality or surface water quality, lakes, streams, that sort of thing, just like commercial fertilizer can.
Manure is a rich resource, and fertilizer isn't the only use for it.
So as the interest in manure has really increased in the last several years because it is such a wonderful resource for crop production and a great source of nutrients, there's been a lot more interest in new ways to use it and new ways to take advantage of that resource. And one of the things you hear a lot about is looking at ways to use manure to produce energy, whether that's to provide nutrients for algae growth or direct conversion to methane or use for digestion into methane. So there's been a lot of systems researched and developed, and is really some neat research going on moving in that direction to where 5-10 years from now we may see manure as not only a great fertilizer but also a great source for other needs like energy. We've got a project where we looked at extracting some of the soluble phosphorus from manure and concentrating that into a form where we could ship it greater distances and use it in a different manner, phosphorus reduction technology like that, to where we can really take advantage of that nutrient source and get those nutrients to an area where they really need them, where right now it may not be economical to get it that far. And so as the industry changes and evolves and starts to see all the potential that's there with this wonderful resource that is manure, you start to see some of these new ideas start to pop up. And I think 5-10 years from now, we may see some really interesting systems that are being taken advantage of by the industry.
People have been using manure for thousands of years. It's no wonder that an entire industry has developed around it.
There are basically businesses that their sole purpose is to transport and apply livestock waste. So there's a number of contractors that go to the feed yards, load up the waste, have already made arrangements to apply it on a farmer's field and apply it at a given rate. There are also, although probably not quite as many, but there's also a number of contractors that offer pumping services. They will pump water out of a waste storage pond or lagoon and apply it on a field. They will provide all the equipment and apply it at the predetermined rate. Because of the increasing complexity and increasing level of regulation, it takes some technology to meet the requirements of the regulation, and a lot of that is taken care of through engineering, agronomic, and environmental consulting services. And that's primarily what we do. We work through all those situations where we determine how much runoff comes off of a facility, how much waste is produced, how much storage capacity is needed, how big a waste storage pond needs to be, how it needs to be sealed to protect groundwater, designing pipelines to pump liquid waste to sprinklers and fields, just a whole host of things. So there is probably a small but active core of people that provide the technology for producers to meet regulatory requirements. Probably one thing that most people don't realize is if you want to produce livestock, if you want to feed cattle or raise swine or start a dairy, it's not a matter of just building some pens or building a barn. There's a whole host of technical decisions that go into that. Obviously, there are the technological decisions about what kind of facility should I build, how big should it be, will it provide the animal comfort and animal productivity that's necessary for it to be a profitable operation. But there's also a significant amount of infrastructure that has to be built in conjunction with meeting environmental regulations and basically implementing an effective livestock waste management system.
The industry has really kind of evolved to include agronomists, whereas traditionally most agronomists have worked on the crop side of things, focusing on crop production, plant health. Fertility was a component of that, but it was mostly focused on fertilizer application, and manure application was a bit of an afterthought. Well, as manure management has become more intensive and manure has been kind of rediscovered as such a wonderful fertilizer resource, the industry has really started to put a lot more focus on pulling agronomists into the fold and looking at, okay, how do we take advantage of this resource in the best manner? And so you see more and more agronomists working in the industry of manure management and nutrient management as opposed to just engineers and folks of that sort that you've traditionally seen in the industry. And so it's really started to open up more opportunities for folks that are really interested in using manure as a resource and have an agronomic background or education. As crop production as well as livestock production has evolved, the use of those nutrients, particularly manure, has changed as well. And so if the producer goes out and gets that laboratory analysis of their manure and they have their soil test, they know where they're going to grow, and they formulate an application rate, it's important that they can actually apply that. And not so many years ago, the ability to accurately apply manure was pretty archaic, I would say. as technologies have evolved, not only have our sampling and analysis got more sophisticated and become more common, the application equipment used to take advantage of that data has really evolved to where we have GPS equipped application equipment. We have application equipment that can be much more fine-tuned in terms of the calibration and how much you're putting on per acre, to where you can really try and get down to a good rate, know what you're applying. And that's important when using manure, because one of the disadvantages of using manure as opposed to most of your standard fertilizers is that you have more variability. And so it's important to a crop producer to know that what they're applying is what they think they're applying. And so good application equipment, accurate application, and good testing all play a part in that process.
Well, ultimately the role the consumer plays here is really important, because for the products that we produce, we're producing them all with the consumer in mind. And so if we're able to better manage our resources in a way that's economical to our operation, we can more affordably produce a product for the consumer. At the same time, by incorporating this technology, better managing the environmental side of our business, we're meeting that social responsibility that the consumer and the general public tells us is important, ensuring that we're protecting our natural resources.
That wraps it up for this episode of Real Ag. We hope the information presented here will make you feel a little better about smelling that stuff when you're driving down the highway. On behalf of the Real Ag crew, I'm Kyle Bauer, helping you sort the truth and helping you understand Real Ag.
Production of Real Ag is made possible in part by an underwriting grant from Kansas Soybean Commission. The Soybean Checkoff. It works for everyone.